Gradient and equation of a straight line. Welcome to this lesson. My name is Justus. In our previous lessons, we had discussed on properties of a straight line, and to mention a few, we said the first property was the gradient of the straight line. We also have the equation of the straight line, the x-intercept, y-intercept, the angle. But in this lesson, I want us to discuss the equation of the straight line. Equation of the straight line. First, let's begin by first understanding that the straight line must have a gradient first. So earlier on we discussed that when we have a straight line AB, we shall consider here where points A is 1,5 and B is 5,1. We still have it alongside on our graph, point A and B. The line joining them shall be a straight line. We calculate its gradient first. So that we understand the equation, let's first calculate the gradient. Gradient of the straight line we had said earlier, but we'll still mention here that the gradient is always change in y divided by change in x. We shall consider the change in y and change in x as follows. Change in y shall be the y coordinate of the first point 5, or even the second one, but begin with the first one in this example, 5, 1. So 5 minus 1, that is the change. And change in x shall be 1 minus 5. 1 minus 5, that gives us the gradient of negative 1. Therefore, line AB has a gradient of negative 1. So we shall begin from there. I want you now to grab your pen and a piece of paper and find the equation of line AB. So equation of line AB together so that we can understand this concept better. Let's begin with the gradient of the line being negative 1. Line AB passes through the 2 points that are known, 1, 5 and 5, 1. We pick another arbitrary point, x, y. An arbitrary point shall give us the equation, because our equation shall be in form of x and y, a general equation for the line. So I shall pick x, y, which is our arbitrary point, and pick point B, which was 5, 1. Remember, we can still pick point A. So later on when we finish this concept, you can pick point A and compare your answer with what we shall find in this lesson. So the gradient of the line is negative 1. I pick my arbitrary point x, y to represent all other points, and then pick one known point 5, 1, for example, in this section. And then we shall proceed as follows. The equation of the straight line shall be, first we try to find the gradient. Of course, we already know the gradient, but let's use the concept of change in y over change in x and equate it to the gradient that is known. But this time round, we use the general point and one of our known points. So let's begin. The gradient shall be change in y over change in x, and I shall proceed as follows. Y minus 1 over x minus 5, x minus 5 is equal to my gradient. So the gradient still remains negative 1. If the gradient of a line is negative 1, it remains that way, whichever the points you pick. That is why when we pick a general point and one known point, the gradient still remains negative 1. Simplifying this equation here, we shall simplify by maybe multiplying both sides of the equation by x minus 5 to get rid of the denominator. So we shall say now y minus 1 over x minus 5. Of course, we multiply both sides by x minus 5 here. Shall be equal to negative 1 multiplied by x minus 5. The x minus 5 on the left hand side shall cancel out. And we are left with y minus 1 is equal to, open the brackets on the right, negative 1 times x is negative x, negative 1 times negative 5 is a positive 5. Collecting like terms together on both sides, we shall take this guy over here to the right hand side by adding 1 to both sides. So adding 1 to both sides shall give us y equal to negative x plus, so we are bringing a plus 1 here, so 1 plus 5 we shall get a 6. So this gives us a general equation for line AB. So for any points on line AB, the equation shall always be y equal to negative x plus 6. This form of the equation is the equation we call y equal to mx plus c. So in this particular equation, the coefficient of x shall always represent the gradient of the line, and then c shall represent the y-intercept, as we shall look at later. So our gradient is evident on the line, so that is the coefficient of x is -1. So remember, the gradient of our line was already -1. So the equation of the line y is equal to -x plus 6. There are many other forms we can write this line, this equation, but let's take y is equal to mx plus c in this exercise. Let's consider the next line, line CD. Line CD, we see it on our graph that the coordinates of line CD here, point C is 0, 3. Let's consider C is 0, 3. Point D is -5, 0. And pick now your arbitrary point x, y. So I want us now to proceed by calculating the gradient first. The gradient of line CD, we can see there is change in y over change in x, and we can proceed by saying now change in y shall be 3 minus 0, 3 minus 0 over then 0 minus minus 5, 0 minus minus 5. This gives us 3 over 0 minus -5 is a +5. So the gradient is 3 over 5. Let's proceed by calculating the equation of the line, finding the equation of the line. Pick your arbitrary point x, y, and any of the points that you think it's simpler to work with. So today let's pick 0, 3 here. So let's begin with the gradient as 3 over 5. Let's consider the point 0, 3 and our arbitrary point x, y. So let's calculate the equation of the line by first finding the gradient and equate it to our known gradient. So I shall say change in y, y minus 3, y minus 3 over x minus 0. So x minus 0, we can write there, and equate it to the known gradient 3 over 5. So simplifying this, we can multiply by x both sides. Of course, x minus 0 still remains x. You can multiply by x both sides so that we can have y minus 3 over x equal to 3 over 5. So multiply by x both sides to get rid of the denominator. Multiply this side by x and this side by x. The x on the left cancels out, leaving behind a y minus 3 equal to 3 over 5x. Add 3 to both sides, or take this -3 to the right hand side, changes the sign to positive, that is adding 3 to both sides. We get now 3 over 5x and then plus 3. Therefore, line CD has a general equation of y equal to 3 over 5x plus 3. Of course, we see the coefficient of x is 3 over 5. That reminds us of our gradient. So that is the equation there. Then lastly, I want us to attempt to find the equation of line EF. We have EF, coordinates of E are given here, coordinates of F are also given. I want you now to attempt to find the equation of line EF. First, find the gradient, take an arbitrary point x, y, pick any of the points that you can work with here. Proceed as we have done to line AB and CD. Write the equation of line EF and leave your answer on the comment section. Thank you for watching. Kindly share this with your learned friends. Subscribe to my channel so that you can be getting these and many more interesting videos. Bye bye.